The topics of this video are in the realm of file input and output in Octave. File input-output can be useful if we have, for example, data created in another source and we want to analyze that or work with that in Octave. We could have a data logging system that creates a file and then we want to analyze or work with that data in Octave. So we can import that data, and we can also create a file to store data that we generated in Octave. So that would be the output side of things. There are many file I/O functions in Octave, and we're just going to look at two simple ones in this video. We have the save function and the load function. Save is used to write data from a matrix in Octave to a file, and load does the opposite. It reads data from a file and it assigns that to a matrix variable in Octave. In this video, we'll look at the save function and an example, the load function and a simple example, and then another example combining the load function and some plotting. So for save, we must have a matrix containing the data we want to write to a file, and then we supply also a file name. For example, we create this matrix called mymat, and it's a 2x3 matrix of random numbers. And then we call the save function, supply the file name that we want, and then the matrix that we're going to write to the file. And the result of this example is shown here. So this box shows the contents of testfile.txt. You can see there's this header, and then we have the numbers for the matrix. And it's the same data in the file as we had in Octave in the variable. Then on the other side we have the load function, and this starts with a file and it creates a variable. And the name of that variable is either going to be what's in the header of the file, or if there is no header, it will just be the name of the file. So for example, here with this file, testfile.txt, see we have this header, and one of the lines of that header is the name of the matrix that created it. So name is mymat. So using load, we'll clear all just to get rid of all the variables, and you can see we type in mymat and we get an error because that variable is undefined. Then load testfile.txt, and now after this line we have a variable called mymat, and it's just the data that we got from the text file. Another example, say we had a different file, and this one, the name of it is testfile.noheader.txt. It's the same data, but that header was stripped away from this one. So then in Octave, clear all to get rid of all the variables, call load and give it this file, and then we look again for the variable mymat, but mymat doesn't exist. Instead, we have a variable called testfile.noheader. So if there is no header, then the variable name is just going to be the file name. And finally, we have another example. So say we have this file with some data in it, 2 lines, and we interpret this as height and weight. So the first line is height from different people, and the second line is the weights corresponding to those heights. So if we wanted to plot this data, we could run this script here, plotdata.m. The first line is to load height_weight.text. So now we have a variable called what? We have a variable called height_weight, because there's no header in this file, so the variable name is just the same as the text file, or the file name. So we want to extract from that all the height data points, data values. So we create a variable h and assign to it the first row of this matrix, height_weight. And then create a variable w and assign to it the second row of the matrix height_weight. So now this is h and this is w. And then call the plot function. So we're going to have weights in the y direction and heights in the x direction. We're going to have black 6-pointed stars is what this argument yields. And then we're going to change the marker size and the line width. And also the x-axis. We will make the x-axis give a little bit of padding on the left and right side. and change the X label and Y label, and so here's the plot that we get. So you can see the 6 pointed stars. They're pretty beefy because we changed the marker size and line width. We have the different heights on the x-axis, and the x-axis goes 5 less than the smallest height and 5 more than the biggest height. And then we have our labels that we created also. So there was an example of using the load function to plot some data that was saved into a text file.